Hello everyone, so here is Vishwajit Kosti. I'm from Pimpri College of Engineering, currently pursuing my BTech in Computer Engineering. And let's see what Docker is. So here is a small demo video in which I will try to explain what exactly Docker is. So welcome to panel members and respected sir, and thank you for giving me this opportunity to present my teaching skills about the Docker as well. So let's see what exactly is a Docker. So firstly, we will start with one scenario where most of the people face the problems. Why do we need Docker? So generally in software or a tech company, we have a product in which we have multiple teams, multiple modules working at a time, and many other people in a collaboration of a team. So we have many people working with different technology on different platforms or laptops which we have devices or any other operating system which we have. So what basically problem we face, we will see in the next scenario. So let's say you have created an application and that works fine in your machine. So from the scratch, when you started learning or making things, or it may be a hello world program with a C++ on your computer, you may have think like it's completely easy, but you cannot just run that code directly onto the production, or it can't be served to the client directly. So what we have, that sometimes when you push it to the production, it does not work properly because the system configuration or operating system may be different from your local machine on which you have developed, and the server operating systems or configuration resources are different from the local machines. So here comes the problem when developer experiences a lot of problems with this. So what happens that when you surf on your social medias or LinkedIn, you have seen like people just say it works on my machines. I don't know what happens on the server on other machines. So to tackle this problem, here comes the concept of Docker as a tool of a containerization. So why the problem occurs? Like it runs on a local machine but not on a server. There are a few reasons that could be the possible reason. There are, first thing is dependencies. Second is libraries and their version, and third is framework, and fifth is like level features which they have on different machines, and the obviously the architecture for microservices that the developer machine has but not in a production environment. So what happens like suppose we have a project with the index.js or any kind of a calculator which I created on my local machine, and when I tried to push it on the production, it fails because maybe the version may not match the local one. So here's what we have. Even though, like, if you see in JavaScript projects, we have dependencies stored in the package or package.json or package log JSON, something is there. We have listings of our dependencies. So once we transport the project, we just run npm I and get the packages, but it's not completely, I can say, portability, because sometimes on other machines the node version which we have may have the different. For the legacy codes, we have some kind of old systems or old compilers which we use. It may be even in case of Java, some companies use 8 version, while Java has like deployed the 22nd, or I don't know the latest version, but it makes problems, right? So let's see what exactly Docker is. So we need to standardize the way to package the application with its libraries, dependencies, and its version to make it seamlessly less tedious to always configure to the version what we have. Let's say there are two features, which is not two features but two projects. Let's say one is dependent on Java 21 JDK, and the other one is the old on 8 version, 8 what we can say version. So In fact, instead of installing the another configuration or version, we just need something to standardize the way we pack the application. So Docker is a tool designed to make it easier to create, deploy, and run applications by using containers. So basically Docker is just a tool, and the concept which we will learn is called as containerization. So let's see what containers are. How does exactly Docker works? So Docker is just a tool which packs an application, all its dependencies in a virtual container called as an image. I mean, we'll see it later, that run on any Linux server. Okay, so each container runs as an isolated process. So on same laptop or same machine, we may have multiple containers running without any changes in the configurations or without any problem making problem to another container, making it kind of independent containers which do not affect others. So you may have a questions who have studied the cloud computing that we could have used virtual machines, right? But the problem with the virtual machines, they are too slow, and my personal experience is it's much complicated as compared to the Dockers. So if you see the virtual machines architecture, it takes time, but on the dock containers, we can easily use it on our local machines without hampering our original configuration of the systems. So here comes the concept of containers. What are containers? They are lightweight, fast, and powerful concept where we pack or wrap up all the dependencies, its version, and code into a container or a package which is called as containers. So container is a lightweight portable that includes application code, required libraries and dependencies, and the system settings which we have. Container is like a suitcase or a package in which we pack all the needy things, and which can be easily ported to any device. It may be while in testing, reviews, or even in production while scaling. When we create a copy of instances or anything, it makes easy or kind of automated things to create an instance. So why do we need them? Because as I told earlier, what problem is that in a industry, each machine, each server may have different system configurations. To make it a best standardized way or to better resource utilization, we use them. So first point is better resource utilization. That traditional deployment wasted CPU, where RAM, storage containers, and ultimately developers time as well. So here comes the concept as containers, which maximizes the resource efficiency. You can run multiple containers on the same server without tampering each other. So it has a faster deployment and scaling, as I said earlier, with automating the package or ready wrapping of containers. It comes with automation of deployment on a server, or it may be in scaling, and consistency is what we have. So once we have a main code, our main application which we trying to develop will have a consistent system settings or dependency over among all the developers or all the production servers without creating a difference or causing a error due to just different system settings. So these are the three main topics, that is a better resource utilization, faster deployment and scaling. Third one is the main consistency or a synchronization among development time in the production as well. So why containers are lightweight? So if you can compare it with virtual machine and a containers, so virtual machine is something we have a instance created on a remote server. So each time we have to communicate with the server, and we have hypervisor to control the virtual machines, and they have actually separate operating system mounted on for the virtual machines, which makes it a kind of heavier as compared to the containers. So on the other hand, if you see the containers, they have a instance which is shared among multiple containers. So they include only necessary system dependencies, making them small and fast. The main keyword which you can see here is the necessary system dependencies, rather than taking any non-necessary or kind of unnecessary, which will ultimately create a heavier version. So here is one example. If we have an application on Ubuntu VM image which costs us 2.3 GB approximately, will cost you around 22 MB, which is much significant for kind of data usage or even time which we use to replicate the container, so the application. So here comes the tool which utilizes the concept of a containerization. Now we have a clear vision of what exactly containerization is, what containers are, and here is the tool called Docker. Docker is just a platform that implements the concept of containerization. As I said, the process of packing an application, its code, its version, dependencies, libraries, and frameworks into a single portable unit that runs consistently across environments is called, or the tool which we use is called Docker. So why do we use Docker? As I earlier discussed about the use cases of containerization, why do we use exactly Docker instead of virtual machines? First thing, it is portability. Portable means you can easily share the copy of your project or application or snippet of your module easily over in your organization as a developer to any team or testing or production. It may be anything. The second thing is the efficiency, which is regarding the minimal system usage. No full operating system is required. So it makes somewhat which utilizes resources better as compared to virtualization. Sorry, virtual machines, I would say. So third thing is isolation. As I said, each containers are independent. So any system configuration change in one container does not affect to the other container. So it ensures the complete isolation without hampering other containers. It's the feature of isolation. And fourth thing is what, scalability. When we have to replicate instances in a server when the demand is increased kind of, so we have to easily or quickly copy or make a copy of the instance. So here the Docker or the container plays a very crucial role to efficiently copy and create an instance without any creating a overhead or kind of work. So here comes the Docker architecture, what we have. So basically, how do we do it? That we have a Docker engine which is installed on this particular or any laptop or local machine. And whenever we write a code or initiate a project in particular device or machine, we create its image. After all, it contains all the code which we write, the dependencies, the framework, and the system configuration or settings which we have. And once we get it, we run Docker build command on our client side or the client, like what CLI I would say. Once we run or build image, it creates a image which is a lightweight copy or I would say a design or blueprint of a container. Now, what exactly Docker image is? It's just a blueprint of a container or kind of plan metadata which we have, and it gets converted through the Docker engine, right? So, what exactly is? We have a client. It sends commands through REST API through the Docker host or the main thing which we have the new thing is Docker Daemon, which controls all the containerization concept or processes. It is responsible for all the image creation, it's whatever we have. So once we get the command from the client, we process through the Docker engine, which have a Docker daemon. Can see it here. And once we create the image, then if we want to build or what we can say is push to the registry, we can create the container to the image or image to the container with the help of a Docker daemon or Docker engine which now, directly Docker daemon doesn't interfere with the containers or image. We have Docker, not Docker, but container D, which is responsible for actual creations. And for multiple images or containers, we have multiple run C. Okay, so this is the one local architecture of Docker architecture. And one thing which we have is a registry. What exactly a registry is? It is like the Docker host and client is something like a local Git version. And in Git we have, for a version control, obviously we have a GitHub, which is a remote server or remote platform where we store our repositories or can access easily. So similarly in Docker we have register or Docker, which we can see is responsible for a remote image or image storing. So we have multiple like registries. Let's see in the next slide about what a Docker client is. So we have a Docker client or a command line interface CLI where we run our commands like a Docker run, Docker build, Docker pull or push. So in Docker run we create and starts a container from an image when we create a project. While we run Docker build, it builds a container image. The third one is Docker pull, and we pull an image from the registry or the Docker for next. And here comes the Docker client sends the command to the Docker daemon, which then process and executes them. It communicates with one or more Docker daemons. So think of a Docker client as a remote control. You give commands and the daemon does the actual work of the Docker engine which we have. So what exactly is Docker daemon? We have been talking far as what the Docker daemon does. So we have Docker D is the heart of a Docker, responsible for building images and running containers, managing storage. It's like kind of we use hypervisor in virtualization or VMs. Similarly, we have Docker daemon for containerization in a Docker. So basically, it manages storage, networking, and systems resources. It handles communication between the client and registries as well. So here's one example. If you run Docker build, the Docker daemon will create a Docker image for us. If the Docker daemon stops, all running containers will stop working automatically. And here comes the role of a what Docker registry. It's just a central place to store, distribute Docker images. We have Docker Hub as a public registry, just like a GitHub. It's Docker Hub. And for private organizations, we have private registries where you can control who can have access to the images or not. That's on you how organization is. So we end the topic of our Docker. So let me quickly revise what we have studied a long time. Is that Docker is just a tool to implement containerization. It does not. Docker isn't just a what we can say a concept. Concept is containerization, and the tool is Docker. And what we studied is what is container. Container is a package in which we wrap up all the required code, dependencies, frameworks, and system settings into one package called as a container. And to manage this tool, we have Docker, and then comes the role of Docker image. It is a kind of a blueprint of how a Docker container is, which is actually I'd say a application run we use for running the application. And we have quite a couple of use cases. Docker is very useful as an alternative for virtual machines, which helps for scalability, better usage of resources, and consumes less time, saves time, use for scalability, and I would say for synchronization or consistency for application development. So here's all about the Docker architecture, what is Docker, what is containerization, where do we use, and let me know how you got through this one. Did you understand or any feedback which I can consume, or let me know what changes I can make, and any changes or feedback would be welcome for you. Thanks so much to do for this amazing opportunity, and thank you for letting me know this about this opportunity. I am really amazed to say that. Um, uh, Thank you.